For my presentation today, I'm going to talk briefly about the industry trends that we're seeing that are leading to better ways to develop, deploy, and scale websites and applications, followed by what are the best practices that we've learned, followed by what are the best ways to use GitHub in combination with our deployment technology and our development technology to make apps that are more efficient, more correct, and are faster in every possible way. A little bit about me. Some of you I recognize, so we know each other. My background is in front-end development. Back in 2007, I got started with a project called MooTools, which was kind of the spiritual predecessor to React in many ways. MooTools was a project that was early on adopted by Facebook that later on became FBJS, and the rest is history. One part of that history that is really interesting, MooTools overrode prototype.flatten, and then the web could never use it again. And that led to a big discussion over the damage that MooTools did. But overall, it was a really great experience that led me into this path of JavaScript and front-end development. I spent some time creating other projects like Socket.io and Mongoose. And later on, I focused on this idea of developer experience. How can we build the best developer experiences to build great websites and applications? As a company, ZEIT, we started in 2016 with a deployment platform, and later on, a way of creating really slick, really easily React applications called Next.js. This React framework kind of pioneered this idea of zero-config development. We pioneered this idea that the file system should kind of work like PHP, and it should be very easy to just get started, put a bunch of files inside, put a bunch of components inside, and off to the races. We got it started with this idea of empowering developers to do really fast applications. And one of the techniques that we sort of used as a default was server rendering. And very importantly, we didn't think that the web and the applications and websites that you'd build would be just a single page. And we kind of put forward this idea that your project scales by introducing more and more pages. So instead of single-page applications, we kind of introduced the idea of multi-page applications. In 2018, we created a new deployment platform that was based around this idea of static hosting and serverless. We found that the best way to scale your sites and applications is to have no state whatsoever in terms of a server that you have to maintain. And in 2019, we've made a very significant progress in growing this technology. A few days ago, we announced our collaboration with Google Chrome. And part of this has been the idea that in order to make React faster at scale, we have to all work together on marrying developer experience with great end-user performance. We're also introducing this idea of a meta or hybrid framework, where you're in charge of how that page that you are building on top of gets rendered, whether it's a static rendering or static site generation or server rendering, all in one cohesive experience. And where does this all sort of stem from? This stems from an observation that we've made that the industry at large is changing quite dramatically. So we kind of started with servers a bunch of years ago, and really in the industry itself, the idea of creating a server to get started with building a website or building a web application is still a pretty pervasive idea. But what we're seeing is sort of this transition into serverless. If you're a front-end developer, you don't want to deal with creating clusters and containers, even though the parallel track, someone else in this conference is talking about containers. We think that the best way to empower the developer that is kind of working on the last mile on the product is to actually not worry about servers. The transition that we're seeing as well is from the data center to a global edge network. So when you get rid of all the servers, you have this tremendous advantage when it comes to application delivery, where if you export your project, you can put it at the edge automatically. So there's no single location that you're kind of bound to. Broadly as well, with sort of React and Next.js and Vue and Svelte and web components, we're seeing this transition away from the modality that frameworks like Rails introduced, where you would base everything on templates. And we're seeing the emergence of components as sort of the primitive of the entire web. Components that are highly reusable, components that are well documented, components that follow a style guide, components that have semantic meaning as part of broader design systems. And even more interestingly, we're starting to approach this idea that we're transitioning away even from code to, I'm going to use a buzzword here, low code. And perhaps even later on, no code, negative amounts of code. And I think to summarize, really what we're seeing is a transition away from the backend and a transition towards empowering the front-end developer. And when I was referring to this idea of code and no code, I think something that's interesting is that we're decisively focusing less and less and less on abstraction and more on interaction. For example, when you build a design system built of components, you're essentially focusing a lot more on the product rather than the underlying abstraction or code, or even code diffs and Git and all that. Just kidding. So we have this idea that the entry point to the entire universe is the web browser, right? And the web browser is obviously showing up in other places like Electron. It's showing up inside native apps. It's showing up everywhere. But the front is sort of this idea that there's a URL, you open it, and then you have broad access to a wide range of services. Some services are maintained by yourself or your company, where you have an API, such as a REST API or a GraphQL API. But broadly, we're also seeing the transition towards deferring some of the work that you would have previously done yourself to dedicated, powerful, very optimal services. So I like to talk about, for example, headless CMSs, where they're providing a service that you can query directly from the front end or sometimes at build time that is entirely separate and independently scaled and maintained, and you operate with it with an API. And I like to talk about content management because using the sort of metaphor of Ruby on Rails that I was talking about earlier, where it's more server-centric, it's more about scaffolding kind of everything from scratch. One of the beginning of how it was introduced to the world, it was a screencast by DHH on creating a blog. And throughout the years, a lot of people have asked me, like, where is the Ruby on Rails of JavaScript? And my response is, the Ruby on Rails of JavaScript is probably not going to look like Ruby on Rails, because instead of, for example, scaffolding your own blog system on top of your own database, you're likely deferring that work to a fantastic content management service, like Contentful or even WordPress with a headless API. We're seeing the same with persistence, with famously Firebase a few years ago, that gave us this sort of introduction to being able to talk to a data service directly from the front end. Authentication services as well, such as Auth0 or Firebase login or Cognito or Fast, where, again, the front end developer is sort of in charge of deciding what the UI looks like and then deferring all the hard work to an authentication service that has given you an API and ensured that the security surface of your project is preserved, as well as real-time services, payments, search. Everything is sort of becoming a service. And this could seem, on some level, like, oh, all the work, it's done. There's nothing left for me to do. But the other side that we see is that it's extremely empowering to this developer that is looking at everything from the lens of the web browser, because now they have the ability to completely sidestep and heavily parallelize the access to services. And we're seeing this show up in the data as well, right? So if you go to Stack Overflow, the trends have changed dramatically. Everyone used to seek this full stack server and front end combined framework, and now it's all conversations surrounding around, okay, how do you use React to make an API call to this? How do I combine Vue with GraphQL? So the conversation global is also being delineated in this way. And again, we're seeing it in the data in a very, very dramatic way. So the idea that kind of makes this happen is that you can use a lot of JavaScript to sort of, whereas you would have used it on the back end, you can now use it on the front end. You can query APIs, whether you do it at build time or on the front end. And there's also this sort of entry point that is the markup of your project. And what's interesting from a scalability standpoint is that two out of these three are naturally serverless, right? So like you can build out two-thirds of this stack completely statically, and the rest you can defer to ways of scaling and ways of executing code in a secure manner without using servers. So this translates into a world where, again, the front-end developer not only is skipping the idea of setting up a server, there is no need. There's absolutely no requirement. And there's two examples that I like to talk about here. There's probably in this room two types of people. Those of you that spend a lot of time on Twitter, and those of you that spend a lot of time on LinkedIn, and hybrids that spend a lot, like me, that spend a lot of time on LinkedIn and Twitter, and don't do any work at all during the day. So what's interesting about these two applications is that they recently completely revamped themselves, right? So like Twitter started as a project of being a mobile website, and then it sort of succeeded very organically, and it kind of became Twitter.com. And LinkedIn, it was kind of a similar situation. But what's interesting about these two apps is that they both boot up to just a static markup. When you launch these apps, they kind of are behaving more like their iOS counterparts. You boot up to them, and you see the Twitter bird, and then you see a skeleton, and then you see data being loaded in parallel, which, as you imagine, they're querying their own API, but in a modern application, you could query multiple APIs, like I mentioned, kind of concurrently. So these two UI primitives are signaling to me that they're moving on to adopting this model at a scale that is not just small projects, but we're seeing it even succeed at the very high levels of consumer websites and applications. And what's behind this is that teams inside these companies were able to completely reinvent these experiences by just piggybacking entirely on powerful front-end frameworks. Like in this case, Ember and I believe Create React App. And the other interesting thing that we've appreciated from these experiences is that it happened very quickly, and it happened with not a lot of people. And specifically, it happened with people, from what we know, that were very close to the user. People that were very close to caring about design and components and CSS and so on. So really, this is really changing how we think about the entire development lifecycle. From education and training is an example that I like to give, because we're all probably here familiar with the nascent ways of learning about programming. What we're seeing broadly is that if you go to a coding school today, you're probably being taught a front-end stack like React and Redux and style components. We're seeing the proliferation of developing directly in the browser, right? So tools like CodePen or Code Sandbox, they even bundle technologies like Webpack directly in the browser. So they're mixing the medium that you're using to develop with the medium that you're using to deploy, or the actual application medium, or even the trajectory of the web inspector that is evolving to become the tool that you're also using to edit. So Web Inspector today has tools for even persisting CSS back to your editor. And even the tutorials, right? So like if you compare the experience of learning any backend language or any sort of traditional native stack to the idea that you just open Web Inspector and you're editing the web frontend directly. Now, I like to talk about this in the context of someone getting started, but there is even an interesting aspect of that when it comes to debugging. When you adopt a front-end-focused stack, such as this, for example, when an exception occurs, you have one area of debugging surface to worry about. You don't have sort of this duality between server and front-end to worry about. You have one security model to worry about. So like now, all you know is that there is a bunch of static assets being shipped to a client, and they're going to be executed in a safe manner, and you're going to control the authentication and ACL medium back to the server. When it comes to development is where we're seeing the biggest transition of all. So what Next.js pioneered, among other things, is this idea that hot module replacement is not something that you configure. Hot module replacement is something that is an invariant to this model. And we're benefiting here from this ability of just shipping JS back and forth from your local environment to the browser. So this quick video is a little bit sped up, but we recorded it because we wanted to show how easy we've made it, specifically because of this ability to have this direct contact with your creation. We kind of bootstrapped this Hacker News clone from scratch in just a few minutes. And everything from CSS to your React components to The page navigation system is all kind of provided by Next.js for you. So the development experience is drastically superior to what we've been used to with regards to like traditional server stacks. When it comes to design, we're seeing some of the most interesting changes as well. I've recently turned my attention to a stack that is becoming really popular in combination with Next.js, which is Tailwind. And we kind of see the same story here. Not only are we targeting the browser, but we're starting to develop, obviously, because of HMR, but we're also starting to design directly in it. So there's a bunch of screencasts on the web that kind of show off this idea that you start with markup, you throw in a bunch of well-thought-out classes, and you're practically just designing directly in the browser. So this is kind of the testament to this idea of the role of the developer and the role of the designer kind of converging into one. I think when you have the right primitives to start with, combined with this front-end medium that allows you to like just see your changes reactively, you're effectively designing in the browser. And another close example that is dear to GitHub, of course, and I think they were pioneers on this, is this idea that once you've kind of determined what the guidelines are of your design, you kind of come up with a design system, right? So not only are you able to move very quickly if you focus on front end, but if you combine a front end that has already all these primitives that have been built up, for example, in the form of a reusable component system, then you move even faster. And I think from our perspective, we show a lot of examples such as the Next.js one, where you're kind of always confined to your local computer, right? So in this example, the first thing that happened was we booted to like localhost 3000. Let me see if yeah. So you kind of run your local development server and you go to localhost 3000, and kind of the work gets confined to that, simple experience of the browser and your editor. But we're talking a lot about how we've really simplified the stack. We have just a bunch of static assets. We have JS, we have CSS. And I think what's interesting here is that it's directly affecting how fast and how frequently we can deploy. And deploy is that technology that will allow us to escape two things. One is it allows us to escape localhost and share our work more proactively. And the other one that is particularly interesting is that it's allowing us to work more closely with the production environment. So when you think about a developer that is immersed in this world of this really nice separation that, for example, having access to JavaScript, HTML, and CSS that queries APIs on the backend provides, a lot of things really become completely uninteresting. So even the idea of a container, setting up a deployment pipeline, configuring it, setting up SSL, it's really completely uninteresting to this profile of developer that is focused on delivering product results. And I think what we've really appreciated is that this kind of profile worries a lot more about the product, right? So it thinks about enabling or disabling features, customizing the component system, combining them, ensuring that there are effective solutions to the customer's problems, performance, lighthouse audits. These are the concerns of this type of developer. So really what we went from is this world of I had a lot of config and it had a lot of state to worry about, it had a lot of clusters and containers, to I don't have anything other than a URL that I can deploy with one command, and that gives me access to a snapshot of that kind of front-end heavy work that I was doing. And what's interesting as well is that one of the particular integration points of this system is the code review process, right? So when you first interact with this continuous deployment technology, you can add it on top of your Git workflow so that every push and every PR gets automatically deployed. So what happens really is that we're shifting from code review to deployment preview. And I think what's interesting here is that the code sort of takes a backstage to the ability to access through a URL the actual work, the actual pixels, the actual interactions that you've been working on. So from review to preview, and of course you will continue to write and read code, but there is an argument to be made about being a lot less reliant on that idea of just reading a diff and then optimistically merging and hoping that you got your tests right. And in fact, this profoundly impacts even the way that you do tests. And I'll talk about that a little bit later on. So what it looks like in the context of your GitHub system is when you install our app, it says now it'll deploy it automatically. Every push that you made, as you see on the right-hand side, gets its own deployment property. Now, what's interesting here is that we're registering a check, but we're also telling GitHub that we have a deployment. And this is kind of one of the very interesting features of this system, is GitHub knows there is a deployment. So I'll show you a quick demo. Earlier today, I was on GitHub, and I was on the Explore tab, and I came across a very interesting project. So it was a new way of creating a credit card form that was originally written in Vue, and this woman, Jasmine MIF, decided I'm going to port it over to React. And this looks great. I have the ability to see exactly how it works, but I was kind of like looking around, and I was like, okay, I would like to try this out. So what we did is we told this user, hey, how about you deploy it, right? Because by deploying it, you now can give everyone the ability to interact directly with it. And because we know it's a simple front-end project, it should be very easy to deploy. So I'm going to go and open sort of our project creator tool here. I'm going to say I want to deploy under Guillermo Rauch, and it's coming from this repository. And then I'm going to say that actually I also want to clone it for myself, and I want to create a private repo. So it's going to take all the code that was in that repo. It's going to create a repo for myself on GitHub. But obviously, it's not going to stop there. What's interesting about this is, OK, now I have that front-end code, and I want to get this URL back that will allow me to share it with everyone in the world. So my project gets created, and the deployment begins. So what's interesting is deployment, when I talked about this idea of, oh, there's just HTML and CSS, it's kind of an overly simplistic view of today's front-end world. Today's front-end world is a little bit more complicated than that. There's usually, for example, a build process, right? So this example is a create React app application. So I'm going to briefly show you the logs. OK, it's already deployed, so I'm going to show you what it looks like really quickly. So instead of my GIF, I now can interact with it. I have my deployment. It has, obviously, its own unique URL that I can share with anyone. It's live rather than code. But what's interesting, too, is that the system automatically built and pushed to production the code that was already on GitHub. And I have the ability to do so not only for just this initial version, which we'll call our production deployment, but I can do it for every push in the future. So this is where it gets even more interesting, right? So I mentioned earlier that I got my own copy of the repository, right? So I completely stole this repository. It's private. I have the ability to, and I'm going to use the awesome GitHub UI here. I have the ability to continue to make edits to this. And without affecting production, I can create this, let's call it code review, that is actually based on actual improvements. And I apologize, I can't see much. So I'm going to do an atrocity here. I'm going to add some code. So the GitHub inline editor has a very convenient feature here, which is that it could commit directly to my master branch, but I don't even know if that looks good. But instead, I can propose a file change that can later on become a pull request. So I now have my code change. Let's take a really quick look at it. OK, again, it's code. I cannot see what it looks like. So let's instead create a pull request. And typically here is where the workflow, especially for a product-focused team, kind of breaks down, right? Because, OK, I made a visual change to my project. How come all I get is a boring code diff? I want to see what it looks like. So as I mentioned, we kind of go through the process of building and readying your project. And then we're going to give it a unique URL. So my ugly addition to this beautiful project is there. And again, I get this sort of unique snapshot of my front end that I can share with my team. Now, this idea of just sharing with your team is not entirely new. It really is not entirely new. This has been done before. But what's happening that we're sort of seeing every day, and it's becoming more obvious to us every day through multiple improvements that we've made to the underlying system, is that the constraints that this has have tremendous benefits. One that is really obvious is it's dramatically faster to deploy. It's zero config. Notice that I took a random project that was on GitHub trending today, the beautiful sort of card thing, and I just added it. I said, new project, boom, zero config. Everything that I typically worry about as a server person got figured out for me, including a global CDN that makes things really fast to serve, HTTPS with Let's Encrypt, and like all that not fun stuff. Interestingly enough, it has no single point of failure because that URL is kind of, it has the ability to like infinitely scale and kind of show up everywhere without, being down and things like that. And as I mentioned earlier, there's this advantage of a security model that just is very, very easy to understand. So as I mentioned, I think that the benefits of getting this URL for every step of evolution to your code is interesting, perhaps not entirely new, until you start considering sort of the performance improvements or the features of the model when it comes to scaling and distributing your project. But I'm going to talk about where this gets really, really interesting. So I mentioned earlier that URL that I got is as good as any other production URL, including, for example, the definitive domain of your project, like google.com. Like, let's say I'm going to deploy that beautiful credit card form to google.com. So you've probably heard of this idea of testing in production. And obviously, when I say this, a lot of people are like, oh, testing in production. No, I don't even deploy on a Friday night. I'm not going to test in production. But there are two features here that are interesting. One is the environment is the same, right? So like that URL had, even though it didn't have the exact domain, for example, it has an environment that completely mirrors production. It's served by the same CDN. The CDN behaves with interesting features like caching and EAT tags and rewrites and all kinds of different features, but it's going to be consistent with how production works. When it comes to testing my backend, it gives me the ability to go directly to the real data source. So in a lot of cases, when you have an API like your GraphQL API or you're querying a headless CMS, you have the ability to, this new front end, query the actual data that then the eventual front end that goes to prod is gonna query. So I've been a big proponent of this idea as well, that real testing happens when you mirror the end user. So you can write as many unit tests as you want, but then you went to the credit card form, and then there's a new div that overlaps the input. And then I've lost all my revenue because, I don't know, like I can't type into the input. So it's not only just that the environment is the same, but the other property that makes testing really interesting is that you can replicate as closely as possible what the end user does. So I have two viral tweets that I'm really proud of that when I die, I want them printed out next to my grave. Just kidding. But they're fun. One is write tests, not too many, mostly integration. That is a riff of eat food, mostly plant, not too much, mostly plants. And the other one, I guess I'm really been on this thread of really funny testing tweets, is in God we trust, all others must bring end-to-end tests. And it probably said that when we didn't have an end-to-end test, and I was kind of reminiscing on what would have happened, what could have been. So the interesting thing about that URL that I talked about is that it really puts the deployment as the center of gravity. All I do every day from the moment I wake up to the moment I go to bed is deploy, 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 and deploy. That's all I do. So the deploy URL is sort of this sort of center of gravity. And the interesting thing is that once I have that prod-ready URL, there's an ecosystem of possibilities and applications that opens up to me. For example, I can perform end-to-end tests against that. I can perform screenshot diffing. So I earlier talked about, okay, what happens if a div moved on to my input and all my unit tests pass, but all of a sudden I can't type. I can actually diff what it looks like. I can make assertions about content being returned by the HTML or content appearing in my function responses. I can make assertions about performance and conformance. I can do cross-browser testing, like do some really quick, boot it up in Safari and hope it doesn't break and things like that. I can actually do really scalable user testing by shipping that URL to a set of people that are going to give me feedback on it. And I can get feedback internally much more quickly from my own team, obviously. And I can do as much manual QA as I want, right? I give you this URL typically on Slack or Jira and say, hey, take a look and just tell me if this feels good, for example. Things that it might not be as easy to do automatically. So in practice, this is enabled by that property that I mentioned earlier, which is that our system will signal that there is a deployment. So it's not just a regular check, like it would be with Circle CI, for example, or Travis CI, or GitHub Actions, but it's a deployment, right? If I have a deployment, then my screenshot diffing tool can wait for the deployment to be available. Now it has a URL that's really snappy that it can launch a bunch of screenshot tests against. I can do assertion testing, as I mentioned. I can do cross-browser testing. I can do, I'm a really big fan of this. We're starting to create stories that are very important to our system. Like, you're probably all familiar with the idea that you continue to evolve your system and you live in this sort of black box of you know everything about how to log in and sign up, but one day something moves 1 inch to the left, and then your file kind of just got ruined. So we started to create with this GitHub app Checkly a lot of the critical user stories that we want to have the certainty that they get completed before we merge to master. So our system, ZEIT now, in combination with GitHub, then creates a gravity around deployment that enables a bunch of super interesting applications to do things that you typically were doing earlier, either maybe not completely, or you were doing them with code, and perhaps now there's tools that allow you to do it with beautiful UIs. A great example is that we used to write tests, like end-to-end tests with a lot of code. Or we used to get more distracted by unit tests. But now I install Checkly, for example, and say, hey, go here, click this, click that, boom, off to the races. And not only are we able to test more effectively and ship with more confidence, but we can also ship with less confidence, which is very interesting. So typically, the behavior of our system is that you merge, and that goes to prod. You merge, goes to prod. OK, so if I had truckloads of confidence here because everything passed. We have like 5 systems of testing. It's pretty insane. So super confident. So you merge and you go live. And even probably during this talk, my team has been doing that, right? Because they're so confident. But in reality, there's always the stuff that goes wrong, right? Like we're not perfect, and we always want to balance agility with the ability of making reasonable mistakes. So an interesting property of this is that you can very quickly revert your PRs. So I mentioned earlier that every push gets a deploy, which means that when you revert, likely that deployment that in this case, for example, took maybe 20 seconds, already existed. So we automatically diff, and we apply the previous deployment with 0 milliseconds, not 20 seconds. So this is a fairly good property. Really fast reverts will increase your ability to confidently ship with no confidence. But toward the future, we envision even better ways of experimenting. So we're starting to integrate with third-party providers to do this, but basically, when you build, for example, your Next.js project, you can tell Next.js, hey, I want this page to have 2 variants, and I want this variant to have access to a smaller percentage of the traffic. And that in itself is pretty good because you're constraining the delivery of a new feature to a smaller set of users. But what we are able to do as well is that we're able to get data from it, right? So there's a constant flow that completes the feedback loop where if, for example, tools like Sentry tell us, hey, there is an increased exception rate on this new page that you just shipped, and you were, it works great on Chrome, but going back to the example of testing, it is common that we test more with headless browsers like Puppeteer. So what about Firefox? Okay, you might have missed it. What about the error rate increased only on Firefox? Automatically revert my project. And again, because our system will ensure that these reverts are atomic and snappy and global, you start experimenting with more confidence, not just shipping with more confidence. Okay, so this is, in a nutshell, the system that we've evolved over the past few years. We're very lucky to have amazing customers using it in production, and a lot of you using it on GitHub, the GitHub app ecosystem. But for those of you that haven't tried it yet, the easiest way to sort of recap everything that I've talked about today is ZEIT.co/GitHub. Do not go to ZEIT.co/GitLab under any circumstances. We don't like that here. Just kidding. And also, please follow us on Twitter at ZEITHQ. And I believe we have a few minutes for questions as well. Thank you. Great question. So he's asking who's supposed to create the APIs. So I think it's a mix, right? I think the trend of you exporting your own API is a real trend today. So I think most projects nowadays are probably already working under the assumption of a hypothetical third-party client that is not just your front end. So RESTful APIs, GraphQL APIs are great fits for this, as well as standalone services that are giving you this out of the box, right? Like instead of creating your own payment API endpoint, you're saying, oh, I'm going to talk to Stripe directly, for example. So there's that kind of broad category. The other category is we want to empower the front-end developer to have the same mental model of scalability and global distribution and speed and fault tolerance that you get from just front-end code, but for back-end code. And this is where, for example, Next.js now allows you to define an API directory where you define your serverless functions. So you can kind of structure your project as your pages that are all going to be your front-end pages. And then you can say, OK, I'm going to define a API directory, and I'm going to start introducing functions that can bridge the gap between backend and frontend. And the way that we see this in production is that, for example, I showed earlier, our system has the ability to take screenshots of your projects, right? So the way that we did that, the screen's gone, but the way that we did it is like we didn't wait putting on the front-end hat. We didn't wait for the API team to figure out how to create that, because we knew that it was a feature that was particularly interesting to the front end, but we knew that it required back-end execution. So we just defined it alongside our Next.js repo inside the API pages directory. And then we just deployed it all together, and it has that same cohesion as the front-end code. And that's why you have this view of build, and you have a view of runtime. So if there were functions that are doing something in the backend, you would have seen them in runtime. Like I said, the broad trends that are probably already going on in a lot of projects, even when I look at things like WordPress and the REST API plugin, or when I look at how Rails has shifted toward being an API server a lot more, we kind of find a very nice cohesion of these two worlds.
With my experience with maintaining a large set of end-to-end tests that go against live production, there's usually idiosyncrasies in those production services, whether those services have downtime problems or they have changing. Perhaps the services you're baking on are not as resilient or fault tolerant or as predictable and reliable. Have you found anything as you've been working with customers who are using live production back-end services? Any type of ways to sort of help them eliminate false positives that may be as a result of those downstream service problems?
I would say I think your observation is correct. I think there are broadly two categories. There's customers that prefer to have a completely different staging API server, and we give them the ability for all their deploy previews to have customized env that they target that staging environment. And we're working on even making that more ergonomic because we see it as a very common trend. But also, when we look at, testing against production, we find that there's versioning schemes that people are putting in place to prevent sort of regression so that their front-end aligns. There's also this assumption that when you move into kind of the SPA type front-end, you don't know that there could be multiple versions of your front-end running at any given time, right? So like the ability to maintain this kind of backwards compatibility of the API has been more of a concern. I think rightfully so. I think it's a good thing because of these fronts that load once, and perhaps you have them open for very long sessions, right? I think for me, Twitter is a great example, right? Like I very hardly ever refresh that. So the versioning, being mindful with versioning of your production APIs will allow that this system continues to sort of have this congruence of, oh yeah, I can confidently run my test and it's going to go to like data that works. And when it comes to flakiness, I think that's interesting, right? We debate this a lot. And I think the flakiness of your end-to-end tests kind of creates this lower bound on the flakiness of your user experience. So I think if I experience flakiness with some of the systems that we've configured, it's just some flakiness that the end user would like, at least some subset of end users would experience. Now, it is true that maybe that's within your tolerance of your SLA targets or the quality of service that you want to provide. So apps like Checkly, and we work very closely with that company, allow you to, for example, retry some of the assertions that you think are more complex or have more time variance, or will allow you to say, this one I don't care as much about. It's an interesting data point if it passed, but it's not required. So I think GitHub checks in that sense are very, very useful. And going back to that idea of it really allows you to ship without even seeing the code, which is obviously a pipe dream. You have to do code reviews, but one thing that we've done is we installed a bot called Kodiak that'll automatically merge certain categories of PRs if all the tests pass. And we can do that with quite a high degree of confidence. Like we send a PR, all the checks pass, and it auto merges. So the PR kind of becomes a kind of like a dumpster fire. Like if it didn't auto merge and it fell under categories of the ones that should auto merge, then it becomes a thing that you have to put your attention on because like, hey, like something went wrong.